This is a really good example here. We can see in the background we're having material flying out. This is a pretty violent blast. We can see the face is barely moving compared to the top of the shot. And we can see cratering directly occurring, for example, in this region here. However, when we look into the foreground, this is not a stemming problem here. Most people would identify this as a stemming issue since all the boreholes are ejecting. It's not a stemming problem. This is a timing problem. Do you notice how the blaster here timed it so this hole here is firing at the same time that this hole here is firing? That means that this back hole here feels 1, 2, 3, 4 to 5 burdens of material in front of it. So this is designed to have a set burden. Let's say that burden's 10 feet between these holes. It actually has a 50-foot burden, 40 or 50-foot burden, because there's no relief. Remember, each of these holes has to fire, move the material out, and so that way the next hole in the next row has exactly the same burden as the previous. And when the timing is wrong, we get situations like this occurring where we have a large over-confinement, and in that case, well, we have over 1 million PSI of pressure here. There's nowhere for that material to go except up. And remember, when we design stemming, we don't design stemming to hold forever. We don't design stemming to hold the entire load of the explosives. We design for the stemming to hold long enough that breakage can occur and the gas pressure decreases in the borehole. And so if we can't get that gas pressure decreasing through rock breakage, we have to have that stemming blowout, and there's no way to eliminate that. Now, I'll also point out one other thing here. You'll notice that the face here has not moved before the stemming has blown out here. So that is, again, a big problem that's occurring. In this case, that's probably too large of a burden on this first set of holes, and that's why we're getting no face movement, really. But again, the back holes here, that blowout is occurring because of improper timing and the over-confinement that occurs because of that. And the end result is that the blast hole may feel 2, 3, or more times the burden.